Alright, so now we are working back with rational functions, and we are supposed to add and do any simplifying that we can do. So I'm looking at these, and unfortunately we have different denominators, so we need to make those into common denominators. So I'm just going to get some fraction bars ready here. Now what I'm noticing here is that a squared minus 1 factors to be a minus 1, a plus 1. It's what we call a difference of two squares, a dots problem. And so when you analyze that, you realize that this guy already has the a plus 1, and now this one has an a plus 1, but it also has an a minus 1. So it turns out that's going to be our common denominator. And like I said, this guy is going to have the common denominator as well. But in order to have it have the common denominator, we have to multiply the top and bottom of him by that missing part, a minus 1. So let me kind of go off to the side here. So what I'm trying to accomplish is this part right here. So that's, if I kind of reverse the order, that's 2a times a minus 1. And so I can do a little distributive property there. That gives me 2a squared minus 2a, and that's what I'm going to put over here. Furthermore, on the right-hand side, this guy already had the common denominator, so I don't have to touch the numerator, 4a. I'm just going to copy that down. All right, at this point, none of those answer choices are standing out to me, but we can do a little bit of a simplification now. We can actually turn this into one fraction with the common denominator of a minus 1 times a plus 1. Furthermore, on top, we can do some combining like terms. This is 2a squared minus 2a plus 4a. This minus 2a and the plus 4a can sort of combine together like terms, and negative 2 plus 4 would be positive 2. So what I get across the top is 2a squared plus 2a. Now I'd love to say that was done, but again, if you check the answer choices, we don't have that. It turns out we can do a little bit of GCF factoring across the top, which would give you actually a 2a times a plus 1 on top. I mean, if you think about it, 2a times a would be 2a squared, and 2a times 1 would be 2a, so that was reverse distributive property. And with understanding then on the bottom that we have this a minus 1, a plus 1, you realize that there's some canceling that can be done. And that leaves us with a final answer of 2a over a minus 1. Pretty challenging problem, lots of steps. The ones that we normally did in class would sort of like be done as soon as we got here, but we could do a little bit further on that one to try to simplify it. That's just the way it goes. Moving on. Simplifying radicals. So looking at the square root of 112 x squared y. So what we did in class is understand that square root of 112 breaks down like we know a factor tree. 112 should divide by 2. I believe that goes to 56. 56 breaks up to be 8 times 7. 8 breaks up to be 2 times 4. And 4 breaks up to 2 times 2. And so what we learned in class was that we are looking, since we're doing square roots, we're looking for pairs. So I have a pair of 2's and a pair of 2's. That's where this 4 comes from on the outside of all of these answers. Unfortunately, that doesn't eliminate any answer choices for us. So that wasn't super helpful. Furthermore, there's this leftover 7, and they all have that little 7 right there, so that's not very helpful either. Whoa. My hard work just went away. Oh dear. Okay, sorry, I got it back. So at this point, dealing with the number 112 just doesn't do anything for us. We need to take a look at these x's. What is the square root of x squared? What is the square root of the letter y? Well, square root of x squared would just be x. In other words, if you list out, what x squared means x times x, which means I have a pair of x's, which means one gets to come out. And you can see that this one has an x out there, this one has an x out there, this one has an x squared out there, and that makes it wrong. Finally, this one back here has a single x out there, so that doesn't really help either. But what about the square root of the letter y? Well, that's not enough y's to be able to come out of the square root like letter A shows, so A is incorrect. B shows a y squared of all things, so that's not good. And that leaves us with a final answer of D, where that y is left underneath the square root. The next one is a cube root. It's very, very similar to that. Just kind of scanning across these answer choices here. Let's see if we can eliminate some. This one has a 3, a 3, a 3, and that one has a -3. That's interesting. So as we look at this, we do see that there's a -27 right there. Cube root of -27. If you ask a calculator what the cube root of -27 is, it's going to say -3, which means that guy is our only choice. Now, I won't leave you hanging quite there just in case we see one that's not quite as obvious in the future, but you can also think of this little, as far as the A's go, how many times does 3 fit into 8? Well, 3 goes into 8 twice with a remainder of 2, so we should see an A squared on the outside, which we have, and an A squared left on the inside. Furthermore, 3 goes into the little 5 once, so I should have a B on the outside, which we do, and then there should be 2 B's left over, just like we see there. So D is proven over and over again. That's a good answer. All right, simplifying radicals with rational exponents. This situation is going to cause us to multiply exponents. So I'm going to start with just looking at the A's. The A, to get the exponent on that, I should be taking -3 times -4/3. Ask a calculator if you need to, but what you should get out of that is the number 4. So really we should just have an A to the 4th power. And as you look at these answers, sure enough, we have A to the 4th powers everywhere. Now this one shows it on the top. This one shows no fraction at all. This one's got it in the denominator. And of course D is what it is. So what about the number 8? That's what we really haven't talked about. What is 8 to the -4/3 power? What would that even mean? You could just ask a calculator. If you type in 8 to the exponent of -4/3, it's going to give you a decimal, but if you convert that to a fraction, it's going to say 1/16, which gives us basically an answer of A to the 4th over 16, which is what A is. That's the quickest, easiest way I can do that. So again, just as a reminder, take the number, take it to that exponent, just 8 to the -4/3 power. The calculator says it's a decimal, which means it's a fraction. And so that basically gives you answer A, and C is a logical choice. And then if you take -3 times -4/3, exponent times exponent, you get +4, which means it should be on top, not the bottom. All right, a little function notation down here. What about f minus g? So we have our two functions, the f function and the g function. We're supposed to subtract them, so here's what that would look like. 4x minus 9 minus 7x minus 3. This is really just like terms here. 4 minus 7 are 4x and 7x are like terms, so I can do 4 minus 7. That's -3. Furthermore, negative 9 minus negative 3. Be careful with that. Negative 9 minus negative 3. That means negative 9 plus 3, which would be negative 6. And looks like that's D. Done there. Moving on. All right. This function notation problem has us multiplying function f times function g. You guys probably know that as double distribution, or maybe your teacher called it foiling. But the idea here is you stick those next to each other and you just get after it. 3 needs to multiply both of these terms. That's the double distribution part. 3 times 7 is 21x squared plus 18x. And don't forget about taking 2 times 7 and 2 times 6. That's 14x and 12. The biggest mistake is that a lot of you are going to just do 3 times 7. You're going to get the 21x squared, and you're going to do 2 times 6, and you're going to get 12, and then you're going to wonder why these have a third middle part. But that's because these two guys combined together, 18 and 14, makes 32. And I'm just noticing this problem is kind of jacked up. I didn't write this worksheet. It's okay. Those are both the same answer, and they're both the correct answer. Moving on. This is called composition of functions. It's where you stick one function inside of the other. So this means I'm supposed to take the g function and completely stick it inside of the f function. So that means I grab this chunk of algebra, and I'm going to shove it into the x spot there. I'm also going to shove it into the x spot there, which is going to look kind of like this. So we have this x minus 1 thing being squared, plus 2 times that x minus 1 thing, and then we add 5. Still got quite a bit of work to do here. This part is you're going to be tempted to do something silly here, but you need to expand that out in a major way. That's x minus 1 times x minus 1, which then becomes double distribution. X squared minus x minus another x and a plus 2. So that gives us x squared minus 2x plus 2. Furthermore, if I do a little distribution over here, that's 2x. So plus 2x minus 2, and bring down the plus 5. So looking at that, we should be able to get our final answer now. We have an x squared, but all these have that. We have a minus 2x and a plus 2x. Those are actually going to cancel each other out, just because minus 2 plus 2 is 0. And then we have this plus 2 minus 2. Those cancel each other out. And finally we have a plus 5 at the end, which something seems, oh crap, just found my error. Let's see if I can correct this. I just did 1 times 1 and got 2. Did you notice that? You probably did. That means that that is actually a 1 right there, which means this is a 1, which means it doesn't cancel out at all. 1 minus 2 plus 5 is what I'm working with, and that makes a 4. So we get this answer choice. All right, sorry about that. Moving on. F of g of negative 5, that means we need to put, oh, hold on, why does that say that and that says that? I better follow what the problem says to do. Stick negative 3 into the g function, and then into the answer from that goes into the f function. So first, I'm going to find what g of negative 3 is. Well, that would be the square root of 1 minus, and then I input negative 3 into that. Well, that gives me the square root of 4, which is 2. Now I do f of 2 which is to take the number squared plus 4, and that gives me 4 plus 4, which is 8. All right, we got a couple solving exponential problems. This one's a little bit tough to look at. I think what that's saying is 2 to the 1 plus 2x power equals 32. You know, one of the easier ways to do this problem, to be honest with you, I would encourage you on a final exam with multiple choice, is to just take these answer choices and one at a time shove them into x. 1 plus 2 times 4, so 2 to that power, does that give you 32? Eventually you're going to see that this is the one that does it, and I'll demonstrate. If I do 2 times 1 plus 2 times 2, that gives me 2 to the 5th power, which is totally equal to 32. So rather than try to solve it and use logarithms and such, it might be best just to use your answer choices given. Same kind of deal with number 8, or this problem down here. We have 18 to the x power equals 1, so what power would you put up there? And you would just go one at a time, which one of these does that. Now that's kind of a weird answer choice. That's not going to happen on the final, so don't get stressed out. That just means no solution. But it turns out it's this one, because 18 to the 0 power is totally 1, says the calculator. So there's our answer choice there.